Good morning, good afternoon, good evening based on your time zone. So this is part 1 of LWC interview series. So let's get started. The first question is, what is Lightning Web Components? Again, this is very basic question that can be asked in an interview. Lightning Web Component is Salesforce modern UI framework for building fast, reusable and standard based web components. It leverages native web technologies such as HTML, JavaScript, and CSS to create responsive user interfaces that run efficiently on Salesforce platform. LWC creates fast, reusable, and lightweight components. So again, this is very basic question. The interviewer just want to see if you have the basics right or not. They won't go in much deep into this basic theoretical question. Moving on to the next one, what are benefits of LWC over Aura components? Better performance and fast rendering, built using standard web technologies HTML, JavaScript, CSS, less code and easier to develop and maintain, improved security with Lightning Web Security, recommended framework for new Salesforce UI development. So whatever is the legacy project, they might have the Aura component which is previously built, but most of the companies or projects is now transitioning to LWC because LWC can do almost everything that Aura can do and do it better as well. So again, this is very basic question which can be asked in an interview. They just want to see if you know why LWC is more better nowadays. The next question is, what are lifecycle hooks in LWC? Again, this is very important question for LWC interview, because if you are giving LWC interview, you are going to see this question at least once, so you have to prepare this very well and in details. Lifecycle hooks are a special JavaScript method that automatically execute at different stages of a component's lifecycle. We have 5 lifecycle hooks in LWC: constructor, connected callbacks, rendered callbacks, disconnected callback, error callback. So we are going to see all in details with a use case as well. And again guys, if you want to download all the interview questions for LWC, you can check out this website, and from there you can check and download all questions at once. The first one is constructor. Runs when the component instance is created, used for basic initialization. So let's see with an example. Like we have this order status property. If you want to set any default value for this one, you can use it on the constructor. Always remember, whenever you are writing anything on the constructor, the first method would be super. So this is mandatory, you have to write it every time. And then you can initialize this order status as draft. So now your question might be like, why not using order status directly whenever I am defining the property? And that is correct as well, and the best practice as well. So most rarely you are going to see use of constructor in a real project, but it's important to know the concept for the interview perspective, and also to write the cleaner code. You can initialize everything on the constructor, but this is not needed and you're not going to see it more often in any project, because you can do the initialization while defining the property itself. Next one is connected callback. Runs when the component is inserted into DOM, used for initializing data fetching or event subscriptions. Let's see with the help of an example. Let's say whenever the component load, I want to fetch the account data automatically. So this is when you have to write the logic inside the connected callback. So here we are calling the method from this Apex class. We are importing from get accounts. So whatever result I am getting, I'm storing it on the account property here. So whenever the page loads, the account data automatically gets stored into this property. So this is where we can use the connected callback. The another example, if you want to subscribe to any message channel, like we are going to see LMS Lightning messaging channel in the upcoming videos, but if you want to subscribe anything, you have to write the logic inside the connected callback here. Here we are importing the Lightning messaging service and we are writing the logic to subscribe it. And also whenever the page gets removed from the DOM, you have to unsubscribe it as well, which we are going to see on the disconnected callback. The next one is rendered callback. Runs after the component is rendered, used for data manipulation or interacting with third-party libraries. Let's see the example of it. Let's say we want to set the focus on the input field. So we have the input field tag here on the HTML, and we want to set the focus whenever the page is rendered. So we need to use the rendered callback here, and here we are using this .template query selector to select this input tag, lightning input tag, and setting the focus here. So you cannot write this one if the page is not rendered. You cannot use this thing in the connected callback, because at that time the page is not rendered, the HTML is not rendered. So you have to write it on the rendered callback, because whenever this is called, whenever the HTML gets rendered on the page, so now only you can able to select this input tag, right? Whenever you are selecting any HTML tag, you need to write it on the rendered callback. So yeah, this is the use case of rendered callback here. Moving on to the next one is disconnected callback. Runs when the component is removed from the DOM, used for cleanup like removing event listeners, unsubscribe to LMS. So we have seen in the connected callback, we have subscribed the message on the connected callback. So this message might be coming from some unrelated LWC or Aura component, and we are subscribing it into this LWC component. But whenever the component is getting removed from the DOM, we want the subscription to be removed, right? So that's why we have to unsubscribe it on the disconnected callback, and it is getting called whenever the component is removed from the DOM. The another use case for this disconnected callback is, let's suppose you are adding any event listener on the connected callback, but so whenever the component is removed from the DOM, you don't want event listener, so you have to remove it, and that logic you can write on the disconnected callback. Let's move on to the next one. Is we have the error callback. It catches errors from a child component and allows gracefully error handling. So for doing the error handling for the child component, we are using the error callback. So this is the parent component JS, right? So if let's say any error occurs in the child component, this method will get called on the parent, right? So here we can see on the console what is the error. Here we can see what is the stack trace of that error. If you want to see all those details, why the child component is failing, those details we can check on the error callback method. So this is about it regarding 5 lifecycle hook and their use case. This is very important question in any LWC interview, so prepare it very well. Moving on to next question, what is a SLDS and how do you use it? Salesforce Lightning Design System is a Salesforce official CSS framework for building application with Salesforce look and feel. Provides predefined CSS class for buttons, grids, spacing, typography, icons, and layout. Ensures a consistent and responsive UI across Salesforce application. Reduces the need to write custom CSS. In LWC, simply apply SLDS class to HTML element, example SLDS-button and this one. So basically you don't have to write complex CSS classes, because Salesforce is providing you the SLDS classes which you can directly use, and all the formatting is getting applied onto that component. If you want to refer how to write the SLDS on your Lightning Web component, you can come to this website, and here let's say for the button, if you want to see, go to buttons, and here you can see all the designs. If you want to use this design, you can use SLDS button on the button tag, and if you want to use this one, you have to write this, and then all the formatting will be applied onto this button. So you don't have to, you can see like you don't have to write any custom CSS for getting this kind of appearance on the button. It will be automatically applied whenever you use these classes. So this is very helpful, and it also saves a lot of your time while building the LWC component. Okay, so again, for referring, you can refer the Salesforce Lightning design library, and there you can find all the different kind of SLDS classes. Moving on to next one, what is the purpose of render method in LWC? So don't confuse this with rendered callback. Rendered callback is a lifecycle hook, but a render is not a lifecycle hook. It is a method which is used to dynamically choose which HTML should be rendered. It returns the HTML template to display. Useful when a component need to show different layouts based on a condition, user role, device type, record status. By default, LWC renders the component's main HTML file, so overriding render is rarely required. So like whenever you write any LWC component, the main HTML file will get rendered on the page, right? But if you want to override it, if you want to show a different HTML template, you have to write the render. So based on the logic, whatever template we are using and render will override the main LWC HTML component. But in real practical example, you will not require this render anywhere, because you can use the child component to display a different page or different component based on conditional logic, right? So it is rarely used, but for interview perspective, you have to have the knowledge what is a render method. So in this example, let's say we have an admin HTML file, we have an user HTML file, and then we have a different HTML file here which is called dynamic template. So if the value of admin is true, then we are going to display the admin template, and remember we are using this return statement on the inside the rendered method here. So whenever admin is true, it will return the admin template, which we are also importing it here, right? And if it is false, it will return the user template here, which is this one. So based on the condition, it will display the HTML template on the page. So this is how we can use the render method in LWC. The next one is, what are decorators in LWC? This is again very important question. You are going to get asked this question at least once in any LWC interview question. So prepare it very deeply. Decorators are annotation prefixed with @ that provide metadata to the LWC framework and control how properties and methods behave. So in LWC we have 3 decorators, which is API, wire and track. We are going to see example of each one of it. The first one is @API. It makes a method or property public, used to pass data from parent to child or expose child methods to the parent. So the example is like, let's say you have the parent HTML, you are adding a child component there, and this is the child JS. So let's say if you want to pass any message from parent to child, you can write you can pass by using the API message. So this is the child component, and this property message, you want to make it available for the parent. For doing it, you have to annotate this with @API decorator, and you also need to add it on the import as well. So once you decorate it with API, this message will become public and it can be fetched from the parent. And parent can pass value by writing in this format. They can write the property here and they can pass whatever value they want to pass. This value can be from parent JavaScript as well, but here we are hard coding the value. So this message will get passed on to the child component. So it is also used as like parent to child communication. Right, so basically like it is making the property public so that the parent component can pass the value to the child component. The next one is @wire. It retrieves Salesforce data reactively using a wire adapter or an Apex method. It automatically refreshes when reactive parameters change. So if you want to call any Apex method or if you want to get any data, you can use the wire decorator here. Let's see with the help of an example. So we are using @wire and we are calling the Apex class. So this we are importing it here, and this is the class name and this is the method name. So whatever value we are getting from this method, it will get stored onto this accounts property here, and we can use it further in our logic. Right, in this way we can use wire decorator here to get data from the backend side from the Salesforce. And again we are going to see wire decorators in the upcoming videos, as well some of the other wire related interview questions. The next one is @track. It tracks changes within existing object or array values. Rarely needed in modern LWC because assigning a new object or array reference is reactive by default. So in old implementation we used to use track property. So any property value gets changed, it will re-render on the HTML. But in modern LWC, most of the properties are by default track, so you don't have to write it every time. But in some cases where you have the deep mutation, what is deep mutation? Let's say we have this employee object, we have created it, and the value of the employee.name is getting changed, like the property of the object is getting changed. So in this case you need to write the track because the property of an object is getting changed. So whenever name is getting changed, this will get re-rendered and the new employee value will be displayed on the page. If you don't use track here, then the new value whenever change name is getting called will not display on the UI. Okay, so whenever the property of an object is getting changed, you have to write the track now also. But if let's say any of the string or integer primitive data types is getting changed, you don't need to write track anymore because those are by default reactive, and whenever the value is getting changed, it will get re-rendered on the page. And also when track is not required, whenever you are assigning entirely new object or array to the property. So let's say here we have defined this object called employee. So if you are, let's say on the change name, we are using something like this. We are again reassigning the employee to this name and age. So in this case, we are not updating any property. Like in this case, we are updating only the name property. But in this case, we are reassigning the entire object. So in this case, if you have this kind of requirement, then you don't have to write track, because if you are reassigning the entire object or array, then you don't need to have the track property. So it is only required when you have the deep mutation, and it's also not required when you have the primitive data type. So always keep in mind, like in modern LWC, track is very less often required, but previously if there is some project which has already written so many code based on previous models where a track is required, you can still see track on the primitive data type as well, but you can redesign it and change it as well so that it will follow the modern best practices. So this is it about this video. In the upcoming videos, we are going to see more LWC interview questions and answer. If you want to get all the LWC questions, you can check this link here. And also if you learned something from this video, give a thumbs up to this video and also subscribe to my YouTube channel so that you won't be missing the upcoming videos. And LWC, I'll try to cover everything from beginner to advanced so that it will be the one stop for you for any LWC interview questions and answers. Till then, bye and take care.